All right, folks, we're going to take a look at a significance test for population means. We're going to be doing a one sample t-test here. We're going to go through our four-step process, which is going to take about 10 minutes here. So we're going to split this video into two parts. In the first part, we'll start by reading the question and stating what we're going to do, planning it out and checking our conditions. In the next video, we'll actually do those calculations, draw a conclusion, and then take a look at part B as well. All right, so I'd encourage you to pause the video right now and read through this question and see if you can go through the process without me, and then you can watch the rest of the video and see how you did. All right, so we have a situation where we have a machine that's filling up juice bottles. It's supposed to put 12.1 fluid ounces in there. They do a quality check on the machine every hour. A worker randomly selects 4 bottles to make sure that it's doing its job correctly, the machine. If there's convincing evidence that the mean amount of juice is different from 12.1 ounces, or if there's convincing evidence that there's too much variation, that the standard deviation is greater than 0.05 ounces, the machine is going to be shut down for recalibration. It can be assumed that the amount of juice dispensed in 2 bottles is normally distributed, which is great. We don't have to check our central limit theorem or anything for that. All right, so we have a sample. During 1 hour, the mean number of fluid ounces of 4 randomly selected bottles was 12.05, and the standard deviation was 0.085 ounces. So there's our sample we're going to be working with. So we're going to perform a test of significance to determine whether the mean amount of juice dispensed is different from 12.1 fluid ounces. And they actually tell us to assume the conditions for inference are met. That's pretty rare that they're going to let you do that. So we're going to go ahead and go through our 4-step process and go through the condition check just for the practice. All right, so we're going to start off by to state our hypotheses to get us started. So we're testing 2 hypotheses versus each other. We've got the null hypothesis that our mean is 12.1 as it should be. So this is our sort of assumed mean. Then we have our alternative hypothesis that the mean is actually different than 12.1. Notice that we're just saying not equal to, it's just different. That's what we're looking for. It's bad if the machine gives too little juice or too much juice. So just not equal to. We're doing a 2-sided test. We also want to state our significance level. They don't tell us what significance level to use here, so we use the default that alpha is equal to 0.05. And since we're saying mu is equal to 12.1, we ought to say what mu is. So let's define this parameter mu. It's the true mean amount of juice in the sample of bottles. Cool. All right, great. So our next step is to do our planning. Again, this question's kind of weird. It tells us we can assume all of our conditions are met. That's pretty rare, so we're going to go ahead and go through the steps. Great. So in our planning step, we want to say what inference method we're using, a one-sample t-test. This is usually required on AP rubrics that you say exactly what inference method you're doing. This is a great way to get that point. So we're allowed to do this as long as we meet our 3 conditions. We have to have a random sample. They tell us in the problem that we're randomly selecting 4 bottles. The next thing we need is normality. We can again assume this because it's given to us. We can the amount of juice is normally distributed. So that condition is another freebie. Now the only one they don't tell us is the independence condition. So it doesn't seem like we truly have independence here because we're not selecting a bottle, measuring it, and then putting the bottle back into the population to be reselected. So we don't have replacement. However, we can ignore that independence as long as our sample is less than 10% of the total population. So we have to think about, is a sample of 4 bottles less than 10% of our population being the bottles checked